So a probability model is something that helps you organize and make sense of a bunch of different outcomes for a certain situation. We're going to be looking at three different types of models today: frequency tables, arrays, and tree diagrams. So a frequency table, this is a frequency table right here. It shows you how many students prefer a particular sport. Okay, and the question might be, what's the probability that a student prefers hockey or football? That any random student would prefer hockey or football. Well, to figure this out, we need to know the total number of students that were surveyed. So the first step is to add up all these students that were surveyed. So let's say there were 90. Probability for hockey would be 12 out of 90. Probability that a person favors football is 30 out of 90. And so that would add up to 42 out of 90, which reduces to 7 out of 15. Having all of the relative frequencies in a table like this just keeps things organized, helps you look things up a lot quicker and easier. So here we see another frequency table, and they've recorded a number of spins, and they want the theoretical probability of getting green and also the experimental probability of getting a green. So this is a little bit of review from yesterday. Well, theoretical probability first. There's only one section that's green out of 4 equally spaced sections, so it's going to be 1/4. Now, if we want to figure out the experimental probability or the relative frequency, we need to know what the total number of spins are. So we're going to add up this column of spins. That totals up to 80 spins, 23 of which were green. So the probability of getting green with experimental probability or relative frequency was 23 out of 80, a little bit higher than theoretical. So this is kind of a wordy one. They ask us to make a probability distribution showing all the relative frequencies. A probability distribution is nothing more than a frequency table with the probabilities thrown in on the end. So number of shots made. Let's see. Each took 5 shots. 2 made every shot. So the relative frequency was 2 that made all 5 shots. 4, and by the way, the probability for that would be 2 out of 30, since there were 30 students in the free throw tournament. 2 of them made all the shots, so that's 1 out of 15. 4 of them made 4 of the shots, so that's 4 out of 30, or 2 out of 15. 6 made 3. 8 made 2 shots. And then looks like 7 made 1 shot, and 3 people made none. So that's a probability distribution. It's just a frequency table with the probabilities at the end. So now we're moving into something else called an array, and this is a perfect type of problem where you'd want to use an array, because you have 2 events. You're rolling 2 die, and even though you might be rolling them at the same time, it's still considered 2 events. So you got the first die, you can roll a 1 through 6, and the second die you can roll a 1 through 6. And then in the middle here, I'm going to put the sum. So if I roll a 1 and a 1, I rolled a 2. If I roll a 1 and a 2, that's a 3. A 1 and a 3 would be a 4, etc. And so I'll just put the sum of the 2 die in this array, and then I'll be able to answer my question much easier. You're definitely going to want to make these if you see this on a quiz or a test. So what is the probability that the sum is 7? Well, I'll just go through and circle all my sums of 7. Turns out there's actually 6 ways out of 36 possibilities, 6 ways to roll a 7. So that's 1 out of 6. Now, arrays work great when you have 2 events, okay? But if you have 3 things occurring, you can't really use an array. You'd have to use a tree diagram, which I'll explain in a little bit. Okay, so here's another set of problems that really requires an array for you to answer these questions. What's the probability of getting at least 1 5? So you might want to pause the video here, see if you can figure this out. So you can get a 5 on either die. So I could get a 5 by rolling a 1 and a 5, or a 2 and a 5. These are all the ways I could get a 5 on the first die. Now, there's also ways to get a 5 on the second die. So these are all the ways to get a 5 on the second die. And then there's one that's counted twice, but we're not going to count it twice. Obviously, you roll a 5 and a 5. It said at least one 5, but that's still just one way. So adding all this up, it looks like it's going to be 11 ways out of 36. What's the probability of getting a sum of 2, 3, 4, 9, 10, 11, or 12? 16 out of 36, so 4 out of 9. Now, some situations like this one require you to be looking at 3 different events. You can't really make an array. It would have to be a 3-dimensional cube, which would be impossible to draw on a flat sheet of paper. So a tree diagram is a much better way to do it. You're looking at flipping a nickel, diamond, quarter, and you want to see what's the probability in the first situation of getting only one heads. Well, I'm going to tree out the whole thing. So with a nickel, you can get heads or tails. Now, if you get heads with a nickel, then the dime could be heads or tails. So far I could get heads, heads, or heads, tails with the nickel and the dime. Now, if I get tails with a nickel, I could also still get heads or tails with the dime. And then I'll tree this out with the quarter now, heads or tails in each one of these situations with the quarter. And so my possible outcomes, if I'm reading across, would be heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So now that we've got all the outcomes listed, let's check this out. Probability of getting only one heads, only one. So the first one wouldn't be good because that has 3 heads. This has 2, 2. So this one's viable, so let's mark this one. No, that has 2 heads. This one has only 1, and this one has only 1. So it looks like that's 3 out of 8 probability. But that's a complicated problem. You can't do that any other way than making a tree diagram. Now, getting at least 2 heads. So this one would count. So with this one has 2. The next one, no. This one has 2, and it looks like that's it. So that's 4 out of 8, which reduces to 1/2. And here's your mistake of the day. Just bizarre. I wonder what state this was in. All right, have a good one. Talk to you soon.